Hello and welcome to Demo Day. We got another one with Trey Ford and Jimmy from RAD. Now, we have actually seen this or part of this before. So this is a little unusual because we had some bad technical difficulties involving a chainsaw. So the internet went out while Jimmy was doing the presentation. So we decided to give him a mulligan on that one. And so we're going to do it again. So Trey and I are not completely new to this, like we sometimes are with these, and in fact, most of the time we are. But hopefully we can still give you the shocked face when we see something cool. All right. So with that, why don't we pass it over to you, Jimmy?
Sure thing. Yeah. Just wanted to say thank you for the second chance. Chainsaws were involved in such is life. Nobody was hurt in the process of that particular podcast. So, all right. So, do you want me to just dive in from just fresh start?
It's your dime.
All right, let's do it. Cool. So, hello, everyone. Hello again for those tuning in again. My name's Jimmy. I'm the co-founder and CTO at RAD Security. RAD Security is a cloud-native security platform. We do a lot of things, but our real emphasis is runtime security with a behavioral twist, if you will. So we've built quite a few capabilities around securing runtime containers, attack path detection, CVE, invulnerability, reachability, et cetera, that I'm excited to share with you all today. So I'm going to dive right in, and as usual, just Robert and Trey, please feel free to interrupt when you see things you want. I'm sure you will.
Just try to stop Trey. It's not possible.
Yeah. Well, it's a good thing to be interrupted if we're diving deeper. So I can share my screen today, which is exciting. And let's do that. All right. So all good?
Mm-hmm. Can see it.
Okay. All right. So to kick things off, this is the RAD dashboard. I just want to kind of give a brief overview of what data we collect to come up with some of these security observations and conclusions, how we get it as well. So from day one, RAD Security has been built to be a real-time platform. So what does real-time mean? Well, if you look historically at many cloud solutions, specifically CSPM or Cloud Security Posture Management, you will find lots of sort of scheduled scanners, we'll call them. So these are traditionally tools that reach into an environment, run a scan, create a report, and then do that over and over again, daily, weekly, et cetera, every 8 hours. A few years back, we decided to take a different approach to cloud native security that is not based off of these sort of cron style scanning implementations. And why would we do that? Well, I firmly believe that most attacks are not always going to fall in magically the window that you happen to be scanning your environment, and things can just go unnoticed, missed completely, etc. So foundationally, we have a few different installation sensors that we place into locations like a Kubernetes cluster or via eBPF that's going to instrument kernel level telemetry or your cloud itself. And we
Jimmy,
ingest data in real time. Go ahead.
Jimmy, one quick question there. So are you saying that other vendors use cron, and if they do, are you saying that an attacker could effectively turn their system off whenever that cron job was scheduled to run?
Correct. Yeah. So cron might not be the exact implementation, but yeah, that sort of methodology of, if you ever see a, kind of last scanned at yesterday at 2 p.m., there's some sort of job that kicks off. And yes, I think an attacker could pretty easily understand when that's going to happen and or just happen to get lucky and not kind of create that combination or that attack path or that problem in that scanning window.
Well, yeah, it seems like at minimum, even if they're not smart enough to figure out when it runs, if they just run for 10 minutes and then stop running and then run another 10 minutes the next day, their chances of them getting caught is extremely slim.
That's true. And I think like to even add to that, cloud configuration, if you were to expose an S3 bucket or a security group to the internet, you can do that pretty quickly, right? Where you don't have to keep it as a long-lived configuration. You could change it for 5 minutes and then change it back. Yes, there'll be some indication in the logs maybe that happened, but the more traditional scanners won't really pick up on that. I mean, the odds of hitting, scanning at that time when that 5-minute window occurred are pretty slim.
Interesting.
Yeah. So in our world, we have these different sensors that are responsible for real-time event streaming. So ranging from the Kubernetes, whether it's EKS, AKS, GKE, on-prem, Kubernetes API. So we use a real-time format to get data from the Kubernetes API on what's changing across all of the different objects in that cluster. Same goes with your cloud environment. eBPF is kind of at the core of our runtime detection. That's doing real-time export of the data as well. And then, we have a variety of different downstream processes that kick off to kind of understand and triage risk and connect those dots. Installation is in the form of, if you're running in Kubernetes, we have a Helm chart that's very highly configurable, lots of knobs to turn and levers to pull to make sure it fits with your particular GitOps workflow. We can install the eBPF sensor in a standalone mode, which essentially means you don't have Kubernetes, but you want to have that runtime protection. We have an installation path there as well. And through our Cloud Connect, we support all of the major clouds, and we utilize a Terraform module to accomplish that. So really trying to be as friendly to the tools that exist in an environment already to kind of plug and play and scale out and make it simple for maintenance. Once you are installed, if you will, it takes all of 5 minutes. We start kind of coalescing that data into meaningful insights. So things like identities that we consume, we'll talk about that shortly. The runtime telemetry, behavioral baselining that occurs from that runtime data. And then we have a graph-based representation of attack paths that we'll see as well. We call those threat vectors, as well as a number of different sort of reachability reports and data presentations that help you triage vulnerabilities in a more effective way. So the end result is really trying to, once you sign up for RAD, it's going to feel like you hired a SOC team, right? You hired an analyst or a team to help triage what is otherwise going to be pretty siloed events that happen throughout your cloud environment. So diving right in, unless there's any questions, we'll kind of look at what the output of some of those things may be. And we'll start with our runtime capability. So just to lay the foundation on how this works, we are not attempting to be sort of like a magical box that you just turn it on and hope that you are protected. We try to surface all of the data that we have access to and the unique artifacts that we've built right in the UI. So you'll see that in a second. But the core problem statement here is really that when you're dealing with ephemeral workloads, applications and containers that are changing rapidly, moving fast, some of them look a little suspicious by design, and some of them are more static. It's really hard to take an environment like that and just apply the one-size-fits-all sort of rule set, right? Whether those are signatures or detection rules, The typical approach here and what we have really aimed to differentiate ourselves from is like, we're going to give you our top 50 things to look for. And anytime we see a system call or a network connection or something or a process that matches that, from that list of signatures or detections, we're going to fire off an alert. That's kind of how the IDS world or an IPS world worked many years ago. And we had a hypothesis that we could build behavioral baselines to not only make our detection efficacy better, but also give you sort of that artifact catalog that you can own and understand how your applications change and morph and grow over time, so you can make better decisions off of drift. And that was the hypothesis a long time ago that we have built and implemented, and that's what I'll kind of be demonstrating here next is that runtime capability. So before we get into the kind of output of what we will ultimately present to a responder, I just want to show you how we come to these kind of behavioral baseline conclusions. So we are able to, through the power of eBPF, ingest some really interesting telemetry. We know when a container starts, we know when network connections are made, we know the process tree, we understand everything about files that are created, touched, deleted, etc. And then we can kind of codify that entire sequence of events into what we call our behavioral fingerprint. And that fingerprint is represented in code, and it has something, again, we're not trying to hide from customers, but it's also not something you have to deal with if you don't want to. So in this case, we're going to pick on the Jupyter Data Science Notebook. If you're not familiar, these are Python-based containers that are typically used by ML engineers, data scientists, data engineers to run queries and kind of have an interactive place to deal with data in any scale. So the security profile of a typical Jupyter notebook is sketchy at best, usually, because you have developers kind of, by design, having a remote code execution style shell into this container to, install pip packages or run, certain terminal level commands. And they're kind of hard to protect because they're a little bit open, by their nature. So what we do is we first, after RAD is up and running in the system, we understand the customer's unique implementation of, in this case, the Jupyter Data Science Notebook. This comes from Docker Hub, but this could, in the same way, come from your own internal registry that you could pull in and have your own special flavor of a Jupyter notebook. So I'm not going to dive into each individual node here, but more just give you kind of a taste of like what kind of events and elements that we capture for this behavioral baseline. So you could see here we have the ultimate beginning, which is our start notebook.py. And these are things, again, when you run a container in Kubernetes, in this case, usually have an entry point and some scripts that start things that fire off when the container comes alive. That's what's being tracked and codified here. And this is the beginning of our, kind of pre-learning or proactively learning what we expect out of this workload. So, anything from like, start sh with our Jupyter lab itself. We have things, another start notebook command. So everything is tracked and traced over the course of time. So why do we do that?
What about like file writes or reads or whatever? How's that? Do you detect that?
We do, yeah. We do detect that. This particular example does not have a tracked file write or read, but we do have, if there's like a touch command that happens or particular files created, we do track that.
Okay.
Same with network connections. We'll see that in a second too. So, really it's all of those elements that flow into the system. And what we do on our side is we reconstruct them in real time into something that you can understand and have that representative sort of, I don't want to call it a bill of materials, but that's kind of what we're talking about here is like, what is my expected behavior at runtime of this exact workload? And does it change over the course of time, right? So you'll see, the first question that we get is like, well, I'm shipping software every 5 minutes. So can you make sure that I'm not, like, how are you going to track that, right? Things change so quickly. Well, we take a pretty well thought out approach on that front because you do not necessarily want to create individual baselines for every unique change that occurs. There's a lot of problems that come with that in the form of noise. So we are going to ultimately be creating this sort of superset baseline that encompasses those changes over time, and you can cut different releases. These are version controlled artifacts, so these are pretty well structured. And then drift is a deviation from what was learned. For us, drift does not equal hair on fire security incident, right? And that's another very important piece of this puzzle. There are certain pattern matching algorithms that we apply. There's certain drift elements that happen through this causal tree structure that are not necessarily going to fire off an alert for you to go investigate right away, but we do collect them and we do not hide them from customers, right? So we're going to see what this particular drift was, this malicious drift, and then sometimes it's just drift. And we put it through the ringer, we analyzed it, and it was not dangerous, so it gets kind of concentrated back into that superset baseline. So that was a long-winded intro to ultimately the end result of that, right? So from a data processing perspective, again, this is done in real time. We're constantly watching behavior as it changes, right? And the first important checkpoint for us is, hey, we don't want to ever baseline malware or something malicious, right? That's another logical question that we get out of the gate is like, that's cool, but what if I pull in an image from Docker Hub that has a cryptocurrency miner that is already running or like runs right away on container startup? Well, we do have a checkpoint for that. We don't create a baseline if that's the case. That kind of just throws up the red flag, and that's the end of the process, and you're going to want to triage that. But in the event that this particular workload is valid and you have different versions of it and it's running and you have it running across multiple environments, we're going to want to continue to monitor the behavior. So that's what you see here. This is the same Jupyter notebook, this data science notebook in kind of monitor mode, right? We've learned what the behavior is. We've codified and represented that behavior as we saw previously. And now we're going to look for deviations that could be risky or an indicator of something, an indicator of compromise. So in this case, you can see through kind of the visualization here, there's a lot going on. You could see we have different sort of elements happening. Some of these are part of the original baseline. Some of these are drift that were not part of the original baseline. Not necessarily important for the sake of the demo, but you can come and investigate what's happening in this workload at a pretty granular level, which is really important. But the thing that stood out here and what we flagged on is that we have this unauthorized access to the Kubernetes service account token. And that is not great, right? Because if you think about the Kubernetes service account token itself, they're automatically mounted in every pod in a given namespace. They may or may not have access for privileged API usage from the Kubernetes API itself. And we want to make sure that this is valid. This is not normal behavior. So what we have done is we've flagged that there's a sequence of drift that occurred that's outside of what we've established. And then we've analyzed that drift as it pertains to the original baseline. And here you could see kind of a general description, right? This could lead to further compromise, where it's happening, the digest itself, and then the important part is around our enrichments. So enrichments in the world of RAD are other things that could be kind of leading indicators to this problem or downstream effects of this problem. So things like, are there vulnerabilities used in packages that are loaded in memory by this container? Is there anything else going on from a CVE perspective that could be an indicator that somebody's actively knocking at the door trying to exploit a CVE, or they did take advantage of that CVE? Or are there other containers that are in a different cluster, different team, somewhere else that are could be affected by this? And then are there other runtime alerts that have been in that kind of sphere of time that could be also indicators that somebody's traversing privileges, abusing this token, etc. So enrichments you'll see in like the modern detection engineering world are just kind of where people are headed, because in a previous sort of implementation, and a lot of what our competitors will do is just kind of match on the signature or the detection rule and then send it to you in Slack or wherever, or Splunk, and you're kind of on the hook to see like what else is going on. And when time is of the essence, that's not ideal. So that's kind of the end result there. We can feed this data to other locations like like I mentioned, Splunk. We have native integrations with Slack. Just a whole kind of collection of places where this data can end up. It's up to you, but this is the result. So I'll pause there.
Excuse me. So I guess I'm a little confused on how this gets deployed. Is this an agent, or are you instrumenting it somehow outside the container, or like how's that happening?
Yeah, so eBPF in our deployment of it is it's a container that runs on each node. The term agent is tricky these days. Everybody has a different, maybe a little different take on agent. We are not a kernel plugin. We are not a kind of embedded in the kernel. So eBPF is a safe way to get kernel telemetry out. You think of your most famous observability tools. Most of them use eBPF. And we do not install as a sidecar right alongside the application. So there's one container per virtual machine that we're monitoring. So if you have a 30-node Kubernetes cluster running in AWS, there'll be 30 containers, one on each node itself.
Gotcha. Okay. And so does that give you the ability to like wire up something so that they can, maybe you don't feel comfortable turning it off, but maybe they do? Like if I see some critical deviation, like it's okay to take this one offline. It's not mission critical, and I'd rather it be gone than racking up money in AWS credits or whatever.
Yeah. So especially for cryptocurrency miners, there's really no real reason that you want to just keep them doing their thing. They're kind of usually also embedded with other nasty stuff. Mm-hmm. So we do offer options there when it comes to responding to certain events. So you could see here, as you are presented with this particular issue, you are given, first you can obviously close the issue if you want. You can ignore it, like most tools would offer you. But we also have a workflow builder. This is unique in that it utilizes native APIs to perform discrete actions against this problem or this target workload. And this is another thing where, if vendors that call themselves, CDR, Cloud Detection Response, I don't really think that the R should just stand for create a Jira ticket, right? You should be able to do something if you want that is a little more in tune with a real response workflow. So in our case, we know this is in Kubernetes, so we kind of if you have our optional Kubernetes operator that's also running in that same environment, if you have that deployed, we're going to present some of these options for you. So in the sense of kind of those options, you have terminate the workload, right? If, like you mentioned, if it's a cryptocurrency miner, maybe I'm just like some developer pulled it from Docker Hub and it's like a head scratcher why it's there. Let's just terminate it. If you're in production and you see something a little more nuanced that you don't necessarily want to just like blow away the workload, you can do something like apply a network policy. So in this case, we are, again, leveraging that built-in operator to create a native Kubernetes network policy. So what happens under the hood, essentially, we're just going to say block all ingress and egress traffic. The target workload is this Python app, and this is the namespace that it's in. If you want to allow an IP address, you can optionally do that, or it's just going to be a default deny for ingress and egress. And this will keep the container running, and it will stop its connectivity to the outside world, which in the form of, when you're dealing with a cryptocurrency miner, they're usually connecting to some pool somewhere. So this will stop that sort of sketchy or outbound connection for you.
Copy. I like the idea of applying some labels to it too. I was kind of curious, like how full featured is this? Could I like run more sophisticated logic and say, look, if it's in this region, or if it's, if it's this time of day, or if this guy's on call, or whatever random thing I want? Does it have that flexibility, or is it more like, look, if you want to get that deep, just set up some sort of thing on the back end, connect it to your Splunk output or whatever?
Yeah, so two answers to that. One is what we're working on right now is more in line with what you're kind of alluding to, which is just more flexible responses, like a true if this then that sort of framework where you can say, hey, I know this is, if I see something in the Jimmy's namespace 123 and it has let's say credential access or privilege escalation as the category, and it happened at, outside of business hours, then terminate, right? Or then label, et cetera. So we're working on that workflow engine now. We have most of that kind of ready, and that's part of our next 1 to 2 month roadmap. The alternative is a lot of our customers already have like a SOAR in place, a kind of vuln management hub where they're kind of enriching this data even further with other elements from like ServiceNow or some other source of record, and that could also be an option, and that is what a lot of customers do today, just with the tooling they already have, like you mentioned, Splunk. Name your SIM. They usually have the ability to kind of decorate the data. But yeah, so we're going to offer enough to do it independently, but we're also being somewhat careful not to just evolve into a SOAR fully, because that's, we're not necessarily trying to be that.
It's a complete SOAR solution. Go in that direction. Yeah.
Yeah, you got to pick your battles.
Couple operational questions. So working from this example, we have a scenario where something is catting access to a config var or a token or something like this. It feels like a signature pattern. We may have a dev that is demonstrating a bad behavior, a dangerous behavior, for whatever reason, probably a good reason.
Yep.
It strikes me that the workflow here, we're going to go back and figure out what pull request, what fed into that deploy. So we're going to work left back to figure out where that came from.
Yep.
Is there anything that's going to highlight, look, this has happened in 13 other workloads. You need to go check these other projects. There may be a developer that's working across these projects and an architect is making bad architect decisions. Like, is there anything happening in that space?
Yes. So attribution is a hot topic for us right now. So
it's kind of like get blamed from the wrong side of Git.
Yeah. And it's challenging, right? Because you don't know. Sometimes there's a ticket, like if people are following the rules, then somebody created a Jira ticket to go do this investigation, and in the ticket they outlined what they were going to do, then that's straightforward. A lot of times that the world as we know it doesn't behave quite that nicely. So usually in this case, when we don't have this particular cat command in a Jupyter notebook um, is not even triggered through like a kubectl exec command. So it's not even like a valid path to get to this file. So that in and of itself already kind of raised it to a certain level. To that end, we can pull in if you're accessing the cluster itself and you're going through kind of valid API access to the workload, we have a whole different kind of side of the platform that we're able to track who's doing what inside of that environment. Now, today we don't pull in, like we don't have we have a GitHub integration, but it's not bi-directional where we pull in all the pull requests and try to map that to a runtime event. We're working on the feasibility of that because, again, that last example wouldn't really have a pull request because it's just
it may
one-off
not, but
command.
You know, if we ignore the one-off command, whether it's invocation of a compromised library or something to this effect, where, gosh, if I've got 3 or 4 people, if everyone on this call is working similar tickets, we may not have a correlation where it's like, wow, we've adopted something that is problematic. We can eradicate this systemically. This turns into one-off work on a loop, which is a serial cost problem for me in my program.
Yep. So the first thing I would do is I would go here, right? So this is, we've invested quite a bit in kind of surfacing inventory in a unique way. So to your question, like, where are all of these, where does this digest rear its head, right? And I don't care what cluster it is, what team it's on, RAD has access to that. And we know, like, wherever we are, we can pull in everything about that digest. So, in this case, we have this problem happening with,
that digest is at the container level, right?
Yeah. So this is at the container level, and we know, but we do have that kind of ownership tree also represented here.
Okay.
So we know which pod, we know which cluster, we know which namespace, like all these different things that are really important to understand if is this a one-off in like a staging cluster that doesn't matter, or is this potentially happening elsewhere, or could it happen elsewhere? So that's kind of what we're trying to get to here.
Gotcha.
I'm and then
trying
these
to think
images. Oh yeah, go ahead.
From a crayon level CISO, simple, smooth brain perspective, my handlers are going to work this ticket. They're going to run this to ground. At some point, they're going to find somebody did something dangerous, invoked something dangerous, added something dangerous, whatever that is.
Yep.
That's a one serial linear workflow.
Yep.
If that library or that pattern or that line of code has been populated into other projects, that's going to land in, I assume, other digest, other containers. I'm looking to see if I can find the point of entry so I can address that and clean that up as a family of bad behavior, right?
Yeah. And I think we have views into that. What we are working on right now is actually also in this enrichments area where we're talking about kind of different elements that may have contributed to this. We are working on an attribution-based model where we're going to pull in other relevant logs, other relevant parts of the system that can help you get to that like root cause.
Gotcha.
Okay. And one of those is again, like, just at the image level, like how many of these containers are running that are using this images? What are the packages? And maybe to your point, are there reachable vulnerabilities, right? And reachable or in use for us means there's a CVE that's part of a particular package that's encompassed in this image, and it's loaded into memory, right? So these are the things that we're trying to really use for for sort of like prioritizing that risk. And you could see at the package level even where we come up with that, right? Like, bash is this particular Ubuntu bash is in use, and it has one medium vulnerability. Maybe I care, maybe I don't. But one thing I want to point out too is what our customers have kind of pulled us towards, which is a really interesting view that's a little hard to get sometimes, is our package level. This is a global package level view. So a little different than what we're just looking at runtime, but this is
runtime SBOM. Yeah.
Yeah. So this is every package that's running across every environment that we can see, and their usage and what image they came from. So
this is
it's
cool.
massive.
This is new, right? We didn't see this.
This is new. This probably wasn't even part of the last demo. Yeah, this is new.
Yeah, I'm just thinking when you see that one vulnerability, it'd be cool to say, okay, like, look, this shows up in 3 other places. It's, I think, because it's custom code, right? I would say this is the antithesis of you're missing this patch for this image. It's this dangerous method has been identified in these other places. And we may be able to correlate, wow, that's Team Blue, and they're working on these 14 images, and it's starting to propagate. We need to stop that pattern.
Exactly. Yeah. And that's, this is new too. A different lens on the same sort of data, but this is at the CVE level, right? As the parent object, where we're saying like this CVE is, we're going to, again, globally, is this in use anywhere, this package, and how many workloads are impacted, right? There's 22 of them working. So we look at some of our big customers, and you're seeing thousands of replications of these pretty dangerous images. And then what I think is really cool is this.
Here's the source images. Yeah.
Exactly, right? Because this is really hard to get to if you've worked in this space, and I know you guys have. It's really hard to get back to like where, like, I know like you don't fix individual packages typically when it comes to like images. You go to the image and like, do I have a fix there?
Hope you have a clean image or get it up to date. Yeah.
Yeah. So this is a really cool view. And then what we also do on that front, before I switch gears to identity, is this is a report our customers also really like, is just straight up riskiest images, because you oftentimes have that question of like, how many are running, how many packages that have vulnerabilities are in use, like what's the blast radius here, and what can if I had 1 week to fix one image a day, what would I do first? And it would be these every time. So that's kind of like an easy report that you can even throw into like a CSV. We've done that for folks who are like, I just want to dump that in a spreadsheet and give it to an analyst, and they're off to the races. So that's all even pretty new stuff since we've last chatted.
So going back to that page you were just on, or 2 pages ago rather, where I can click on the workloads or I can click on the images, can I also identify, can you show me what the workloads are that are currently potentially bad as well? Because some of them I might want to keep around. Unfortunately, I kind of have to, and others I'm happy to kill, right? It sort of depends what they are.
Yeah, so the data science notebook here in this case, it's almost like a reverse lookup. It's the same lookup that we did from the runtime alert, pretty much. So in this case, we have, this is the image that was in question. We have all the packages for it, the vulnerabilities, and then the workloads themselves we can get back to, right? This parent-child relationship. Yeah. So you can kind of go from running container all the way to cluster, actually all the way to cloud if you wanted, through a variety of different lookups that way.
Seems like it would be a nice feature to eventually have out, where I could just kind of click on it, just expands, click on that one, it expands, and that pivoting turns out to be quite useful.
Yeah, and we're constantly trying to. It's so much data, as you can see. We're constantly trying to find the best way to represent it. I think last time we did the demo, we did a bunch of new UI, work in this space. So we have a much more faceted sort of model. We can also, these are all API endpoints too. So a lot of our customers just use the APIs themselves to take data from here, some other system, and kind of patch it together. So you don't have to use the UI, but it is nice if you want a quick look into this. And even on the identity front, right? So it's in a similar way where we're going to show you running containers, images, associated packages. We have invested and continue to invest in our identity-centric sort of view in the same vein. So we pull in this case, we support Kubernetes identities today with a very large expansion coming soon on the roadmap. We're working on that right now into a variety of other identities, but it'll look similar. So what we do here is we pull in static configuration that's defined for basically RBAC. What does a particular identity have access to? And we roll that up across all of your environments. Again, it's really important. A lot of tools tend to be like singular focus on one cluster, and we decided to take a multi-cluster view first, which is way harder from an engineering perspective, but offers a lot more value when you're trying to figure out systemic issues. And we roll these up and correlate them with active audit logs, the things that are occurring, to come up with a very risk-based approach to these identities. So you could see here, these are the identity sources. So we have users, we have service accounts, we have different elements and groups that are constructed here, and we can understand pretty simply what is going on inside of a given environment. So the first thing we do, and this is always one of the bigger problems in IAM and Kubernetes RBAC and probably lots of identity systems, is just I don't know what this thing has access to, because it's never a one-to-one relationship with a file, right? It's usually just this web of trust relationships. So we dynamically build those relationships, and then we report on them in an aggregate. So rarely do people who are doing this kind of work want to just manually go through and analyze each of these individual bindings. We just want one place to see everything that identity can access.
It's an impossible state table to build in your head, especially during an incident, right?
Oh, yeah. Especially when they change every day. It's just so we're constantly making those associations, but we're also analyzing them for things that could stick out, right? So once we have the aggregate, we can say, okay, this cert manager service account can, read secrets. It can manipulate shared cluster networking services. It's talking to the Kubernetes API server. We haven't seen any anomalies yet. These are things that matter during an incident, but also just during regular kind of identity review, reviews, right? Your quarterly review of what has access to important things. We're trying to give you a quick way to answer that. And then we also do a analysis of the actual logs that are emitted from with this source, right? This particular identity. So we know what this service account's up to and what it's accessing, where it's coming from. Is it allowed? Was it denied? These logs are really, really rich in kind of metadata for us to make better decisions on in an incident event or not. And we also use these logs to help you right size the permission set. So this is pretty cool, where we essentially take that aggregate, right, on the left. This is the raw configuration, everything that's associated with this service account that it's granted, right? All the verbs, operations, and everything. We go back 90 days through the logs, and then we do an analysis of what this identity actually used, and then we generate a much more kind of right-sized configuration for you to use as a starting point to help better your, reduce your blast radius there.
At one point, you were saying something about network access is something you also monitor or look at. I don't know that we've seen that feature yet.
Yeah. So let's see. I think I have a finding I can pop up. It's a little bit older of one. Let's see. So we'll do this crypto miner. So from a runtime standpoint, network access is something we track. Yeah, this one doesn't have that. One second. I know I have a network. It's a mocked one. Oh, here's an example. So in this case, we are able to trace from eBPF is kind of still at the core of what we're looking at. If there is a network connection that's established from that running workload to something suspicious. So the way this works, and you can see we call out the domain itself, and we're using curl here. This is kind of a fabricated test, but it would work in the real world also. They get represented as a separate node. So you can see when we run the curl versus when the actual connection is established. So these are just different node types that get encompassed in that behavioral baseline. So we know the address, we do a DNS lookup if there is one. Sometimes we see just raw IP addresses that are strange. We also know if it's like an AWS metadata endpoint, ports, etc. And these contribute to the drift analysis that are in place.
What about stuff like suspicious or bad DNS queries? People tunneling over DNS.
We would see that, yeah. We would know, depending on how they got there, that leaves a few traces, right? There's probably some binary that's executed to begin the tunnel, and then the tunnel itself, we would also see that outbound connection, and that would be kind of analyzed as part of the drift sequence too.
Cool.
Yeah.
So a question I ask everybody, and so you get the question too, is if you had to build some sort of warranty around this product, if you don't already have one, what part of the product do you think is really just bulletproof and you'd give people their money back or whatever because it's just going to work?
I think what you're looking at by design, because we are taking an approach that is not easily bypassed, right? We are seeing everything that's happening at the workload level. So I would put our warranty that we don't have today, but in this hypothetical around runtime attack detection, right? So and the ability to find the needle in the haystack when it comes to that.
Wow, that's the hardest thing I could. That's the hardest thing I think you could have said.
Well, I mean, I could say I can match packages to vulnerabilities that are running. I think, but that's kind of boring. I mean, it's not a boring feature, but I love it. I'd rather go bigger.
No,
than that.
I'm impressed because that's exactly the kind of thing that customers want to hear. It's like, no, we're certain the main part of the product, the thing you are going to be most concerned about, and the reason you came to us in the first place, that's the thing we're going to warranty. That's pretty impressive.
What's it going to take to warranty it?
It's going to take, well, first of all, thank you. I mean, I think just my background is not coming into founding a company, I personally didn't even realize that like that wasn't an option to build the best product, something that's actually going to like work. I've used plenty of tools that don't, that are just total checkbox, like whatever platforms. But I mean, my name's pretty tied to this, so I'm gonna, I'm not saying everything we do is perfect and we have everything completely buttoned up, but we put a lot of thought into this. So I would say that would be something I'd stand behind. And what it's going to take to do it, it's going to take there's a few technical implementation details of coverage that I think we need to beef up before we can have like end to end everything that is possible to detect. I would like to also have better. We have internal test harnesses and frameworks to ensure detection efficacy. There's some are already in play as like external consulting and red teaming to happen to make sure like bypasses don't occur. I think there's a lot that I would want to kind of just have on paper. The tests are complete and we're doing that on a regular cadence before we talk about warranties. Just to be safe.
Yeah, well, that either way, that's great. Even that you're thinking along those lines, because the vast majority of companies I talk to they won't warranty the main part of the product. They'll warranty some small bit of it, but not the core, especially something that's based on finding the needle in the haystack. That's really it's unlikely to work the way that people want it to reliably enough where you're going to give them your money back.
Correct. Yeah, maybe I'm crazy. I don't know.
I don't know. But it's cool to put your money where your mouth is. So you talked quite a bit about different things on the roadmap. Is there anything else you want to talk about in the few remaining minutes we got here?
I mean, we are available on the AWS EKS Marketplace, which is something we're pretty proud of because we love AWS, but it wasn't straightforward to be an early adopter of that particular marketplace. So we are there for kind of a one-click deployment, which is really cool, easy to make, just seamless integration and distribution. So if you want to check that out, we're always writing. I think they're, not run-of-the-mill blog posts. We're always doing stuff that I think is kind of pushing research out there, and our assumptions. So if you want to check out our blog, it's just on our website, rad.security. You'll find our roadmap is, we've seen a lot of success with using LLMs thoughtfully inside of the product. They have a place. So you'll see our goal is to like level up your team. So the roadmap reflects that. We want to bring all the data to one place that you would need to make decisions in an instant at any time, for somebody who isn't necessarily like a runtime or Kubernetes expert, right? I think a lot of tooling out there requires some pretty deep knowledge, prior domain art that's like hard to get, and teams are running pretty thin right now. And I think our goal is to make that experience for anybody who is dealing with that in that moment, and try to make that experience like worthwhile and you can actually make a decision. So our roadmap reflects a lot of that.
Gotcha. Trey, any final thoughts?
No, excited about this. The shift towards heuristics was pretty big for antivirus. We learned to ask a lot of questions about it. I'm very interested in how the baselining happens. I know a lot of that's secret sauce, but excited to see how you do. Excited for this.
Appreciate it. Thanks for the second shot, guys.
Yeah, of course. And one previous conversation we had was around the way you guys use LLMs and how you structure the data in very intelligent ways. And if it doesn't fit this format, it gets thrown on the floor. So you have to get this format perfect. And I don't think there's enough people really thinking along those lines. So it's kind of cool to see LLMs being used the right way in a product, as opposed to just summarize this for me or something, some dumb feature.
The summary stuff is such that's the easy path.
It also just doesn't work very well. Like summaries are, I don't know. I've not seen them be particularly great, but this is a cool utilization of LLMs.
I think so, and I think do people really want a chat bot in your like software security product? I don't know, like that. I think.
Why is it always a chat bot? It always starts with a chat bot.
It's always a chat bot, and we don't have a chat bot. I mean, but I don't know if I would use it. Maybe I would use it, but I think I've had to level myself up quite a bit very rapidly. And once you start getting over certain hurdles of like where you can use some of these modern models they're extremely powerful. I think it's just there's a balance of efficiency, cost, and just like data governance, the things you have to really think about. And I'm glad that we took a little bit longer. I mean, a couple months in the scheme of AI to kind of get our feet under us, because I think it's only gonna get better. So
that's great. Okay, so how do people find you, the product, get in touch, all that stuff?
Yeah, I'm on LinkedIn, Jimmy Mesta. I'm pretty easy to find on the internet in general. I attend a bunch of conferences, so if you see me at KubeCon or Cloud Native Security Con or DEF CON, Black Hat, RSA, please say hi. I'm at our website's RAD.security. We have a blog there. You can follow us on LinkedIn or Twitter or really wherever. And please reach out. I mean, I love hearing what people are working on and how we can help in any way we can.
Well, Jimmy, this is great. Great demo, great pitch. Love it. So thanks for coming on and doing this for the second time. No chainsaws. So we lucked out.
No chainsaws. Yeah, we lucked out. Yeah, appreciate it, guys.
Yeah, thank you so much.
All right, take care.